Probably. I mean, you would expect more seeds if there were pop3 seeds.
Yeah.
You would thus expect more mergers, and then you would get more ejections.
Yeah.
And so, how all of that plays together is, I don't feel confident commenting on what the overall result would be. Other than that, it's another thing on my list to get done in the next several years. Carl?
So I had a couple of different questions actually. So most of these mergers are like 50-to-1 mass ratio. But for your typical, say, black hole in the sort of dwarf galaxy, how many mergers have they gone through over their lifetime? Is it usually just one, give or take, and that one's usually 50-to-1?
Ooh, no. If it's one that stays in a dwarf, it's between 0 and 2, I would say.
Okay.
Mergers in its lifetime. If it merges with the Milky Way, then it does the 1 to 50 thing. But if it stays in the dwarf the whole time, then those are the ones. Those are these.
Okay, and those, yeah,
Pretty
so those
much.
typically have higher mass ratios and
Yes.
higher kicks.
Yes.
Okay. The other question I had was actually about HLX1. I've been hearing about this for years, but I thought, and correct me if I'm wrong, the interpretation would, some people were starting to claim those were actually just highly magnetized neutron stars accreting well beyond Eddington. Geez, I'm not up to date on that though. Is that still...
There are multiple claims of what it can be. I'm pretty convinced that it's a intermediate mass black hole because a lot of there's an H alpha detection, there's the variability, the modeling of the X-ray spectrum matches an accretion disk with a temperature of, I forget what the temperature is, but the mass ends up being 10 to the 5-ish or so. There's a lot of, people have looked at this in all the wavelengths and all the times and all the ways, and to me the best argument is an intermediate mass black hole, but that's definitely not the only argument.
Those are ULXs.
Oh, good work. Yes, they are.
Yeah, yes.
Well, I got 2 of the 3 letters right.
Yeah, so many ULXs are, most of them I would say are probably not intermediate mass black holes. Many of them are stellar black holes, some of them are neutron stars. Some are intermediate mass black holes, but I don't know how many. Maybe 1.
Your conclusions, your first point about staying close to the original seed mass. Do you think this is also true for the more rare subset that merges, or do they necessarily need to accrete mass, or do they in your simulations? So the things that Lisa will see, do you think this will also be true for them?
I think that is true for the ones that Lisa will see. The ones that Lisa will see are also haven't accreted.
Okay.
So yes, when Lisa does see these things merging, I think it's not a terrible assumption to think that, okay, these were the original seeds that haven't accreted. The thing is, we also have to try and figure out if they're in, like, are they in dwarf galaxies? What kind of host are they in? But I think assuming that they're the original seed mass, if we see these intermediate mass black holes merging, is something that we can go with and make some. We can go from there. I think it's okay.
If the seed mass is 100 solar mass, then it may not. It's sort of on the borderline of the Lisa window.
That's true.
So it really depends what the seed mass is.
So
Yes.
Maybe, okay, so then, can you say something about, maybe I missed it, what is different about the systems that merge compared to ones that end up wandering?
That I'm still looking into.
Okay.
In fact, today my intern is working on that at the MBH.
Yeah.
So now that we've identified its individual mergers, I'm having her examine each one individually and look at their host galaxies, look at what the incoming orbits of the black holes are, how long they hang out in the host before they merge, is one central and one comes in, or whatnot.
Yeah.
Looking at that.
Because sometimes if you're pushing the merger together, and I know we're talking about the mattress again, with gas, you need to accrete a order of the mass of the system, but that's not the only.
That's not happening here yet.
So.
Yeah. So I'm not sure how the ones in the dwarfs are coming together, but I'm looking into that today. Sarah's on it.
One more question. So something wonderful about HLX1 and many of these wandering black holes hypothetically is that they might carry a bunch of stars with them, a star cluster. So HLX1 has a star cluster, as you know, that was maybe the core of that dwarf or something.
Right.
So is it possible in the future to model the globular cluster of in your cosmological context, and then ask how the star cluster around the black hole might look different or distinct from that in like spatial distribution, color.
Good idea. Yeah, right now when I do dynamical friction calculations, I add in a fake star cluster mass
Yeah.
sometimes
Yeah.
to compare. In a cosmological simulation, that's going to take another generation to get
Yeah.
nuclear star clusters that are bound to the rock.
We wrote a paper on that.
I know,
with,
Ryan O'Leary.
O'Leary.
Yeah.
Yeah.
But, yeah.
Yeah, so these wandering objects would quite possibly have bound stars with them,
Mhm.
as Ryan said, and as Aki said. But in the simulations, getting stars bound to the black hole is up and coming.
I guess I meant more in a sort of subgrid sense, so like could
Yeah.
there be globular cluster particles kind of thing,
Ah.
where as well as the like black hole plus star cluster particle. and
I think so.
One might follow those over time,
I
not
think-
like resolving 10 to the 6 stars. with
Right.
the globular cluster.
Right. Yeah, we could do that. We could add some extra mass and then maybe have it like tidally dissipate versus time or something.
Mhm.
That's not a bad idea. Yeah. Got some good ideas here. And then get another student this summer.
Magda?
You looked at if there's any significant fraction of triple systems, if these branches reproduce any triples?
I would say that any triples I produce are not physical, and because I don't think we would resolve any of the actual dynamics of a triple system. So I would say no.
And maybe last question, Sonak.
So when you have like a big population of wandering, is there anything interesting about what the gas looks like? Is it like big holes in the gas? Or
Yeah, I've looked for that. They're mostly in the halo, so the halo gas doesn't really care that there's black holes flying through it. They do sometimes punch through the disk, and in that case, there can be some like accretion that goes along with it. So yes, there's some effect, but differentiating that from any other effect like supernova bubbles is it would be tough observationally to say this disk effect is from a black hole flying through versus from any of the other numerous things that there could be. So there are some effects from the gas, yes, but not in a smoking gun kind of way.
Right, well, I think we've filled enough, so let's thank her again.
Thanks everybody for your questions. To lunch. To my other college.
Overseer, that's good.
Thanks for coming, Warren. Yeah, there's a lot of things going on.
Actually, my name is Rosie. Nice to meet you. I think that I'm going to meet you at 2:30.
Okay.
Yeah, I have some questions for you. Actually, about this code, is this a public code?
Number 6.
But I was just trying,
meeting
to
here
find
and
it,
fun,
but I
right?
couldn't
So,
find
yeah,
it
it's-
actually.
That's no problem. I'll let you know.
Yeah, I mean
Probably
the
gonna
best
be,
way that I could.
Yeah, there's definitely a public version
All
of
right,
GitHub
yeah, thank you.
Yeah.
you can get.
Okay. You wrote it, right? This is your.
I wrote part of the one that came before. So I wrote part of gasoline, the black hole of the gasoline. I wrote, and then it was all imported into Changa, and then it was improved by Michael Tremmel.